Chapter 3 on Dynamic Routing Protocol. In this chapter, we look at Dynamic Routing Protocol, what's the purpose of running a Dynamic Routing Protocol, and how do we use Dynamic Routing Protocol together with static routing. In particular, we'll look at RIP version 2 and how do we configure RIP version 2. We also take a closer look at the routing table, the different components of our IPv4 routing table, the parent and child relationship, and how do we use the routing table to route an IPv4 packet and IPv6 packet. Dynamic routing protocol can be broadly divided into interior gateway protocol and exterior gateway protocol. Interior gateway protocol are mainly used within an organization for routing within a company network, and exterior routing protocol are mainly used for routing in a wide area network, normally between the different service provider. Under interior gateway protocol, we can further divide them into distant vector and link state routing protocol. In this chapter, we will look at RIP version 2, which was an update from RIP version 1. Basically, the update is to accommodate growth in your network. But if your network becomes too big, RIP version 2 may not be able to support it. Then you need to either run EIGRP, which is also a distant vector routing protocol, or you need to run a link state routing protocol like OSPF or ISIS. For exterior gateway protocol, the example we have is BGP, which is used for routing between the ISP. Why do we need to use dynamic routing protocol? Dynamic routing protocol is basically used to discover remote network. If you remember, remote network are network that's not directly connected to you. For example, R1 have a network, for example, connected to here, network 1 is directly connected to R1. He does not need a dynamic routing protocol to help him. But if there's a network here that's connected to R3, network 3 for example, then R1, because it's not directly connected to network 3, it requires someone to tell him this network exists. So we can use dynamic routing protocol to help him. So R3 basically will send an update to R1 telling R1 that this network exists. The second purpose of dynamic routing protocol is to maintain up-to-date routing information. So as and when you add new networks, then we will have you need R2 to update the other routers that this new network exists. We can use dynamic routing protocol to help us. The third use of dynamic routing protocol is that you can choose the best path to the destination network. In this example, R1 can use this way to reach network 3. It can also use this way to go to network 3. So which way will you choose? We can ask the dynamic routing protocol to help us choose the best path to reach the destination network. And finally, if the best path went down, let's say I want to use this path and this path goes down, maybe due to the link went down, the R1 is able to find a new best path, that's to use the alternative path automatically when the current path is no longer available. So that's the four main purpose of using dynamic routing protocol. And the main component of the dynamic routing protocol will include tables or database that is kept inside your RAM. This will be your routing tables. Your routing table will be kept in the RAM, and dynamic routing protocol will use this table to decide how to route the packet. Routing protocol messages. These messages are sent between the routers. To discover new routers, to exchange routing information, and to maintain accurate information about the network. And finally, algorithm, to learn about new networks and to determine which path is best if there's two or more alternative paths to go to a particular network. So this algorithm will also be one of the components of a dynamic routing protocol. We are looking in the earlier chapter, we look at static route and how do we normally configure and use static route. So in a network, usually we have both static route and dynamic route working together. So static route is normally used when your network is small. Like for example, if you want to route packet to and from a stub network. So this is an example of a stub network, okay, where there's only one way to go inside this network and one way to go out of this network. So this part is considered a stub network. Okay, so for this kind of case, okay, for R2, okay, R2, okay, there's only two networks over here. And that's the only way to go into this network is through R1, and the only way to go out is from R1. Since there's only two networks over here, you don't really need a dynamic routing protocol to help you run, because there's only one way to go in. So in this case, we can use static routing on R2. Okay, you can create two static routes, one to go to this network and one to go to this network. And the only way is to exit out of this interface or using this as the next hop. Okay. And another use of static routing is on your default route or your gateway of last resort. So in this case, for R1, okay, the only way to get out of his network is through here. Otherwise, there's only two directly connected network over here. So for R1, we can configure a gateway of last resort or default route, okay, to exit from 000 to go out. Okay, so we can just use a default route to go to any network that I do not know, okay, to go to the remote network. So in this simple network, we can just use a static route instead of dynamic routing protocol. What are the advantages of running static route as compared to dynamic routing protocol? A static route is easy to implement, especially if you have a small network. As we have seen earlier on in the earlier example, okay, if you have a very small network, just one or two static route, you are able to route packet between the remote network. Okay, and it's very secure. There's no advertisement that's been sent as compared to dynamic routing protocol. So in dynamic routing protocol, if you connect routers together, for them to know about remote networks, okay, the router need to send update information, and this will contain information about this network. So if a hacker managed to enter into your office and connect his own router to your network, he will also be able to receive the update information, and then he will be able to know your network topology. Okay, so it's less secure, but static routing protocol will not have this problem because there's no advertisement that's been sent. And the route to the destination is always the same because it's static. Okay, how to you route packet from one place to another place is always the same. So it's easier to troubleshoot. Okay, and it's easier to understand how your network runs. And also because there's no routing algorithm or update mechanism that's running on the router, okay, it does not take up additional CPU time, does not take up additional RAM space, okay, in order to run. Okay, static route does not require extra resources. Okay, but dynamic routing protocol will eat up some of your CPU, eat up some of the RAM, okay, so they can make routing decision. So you need extra resources. So it tends to slow down your router. Okay, disadvantage of running static route is it's usually used for a very simple network, okay, or for default static route. If your network grow bigger, okay, your complexity will increase dramatically. Okay, as you learned in last week's lab. Okay, where your network become very big, it's become very difficult to configure and difficult to troubleshoot when there's error. And when there's error, okay, and you want to reroute the traffic, you will need manual intervention. That means you need to be physically at the router there to configure. Okay, it will not automatically switch to the next best path. So when your network become too big, okay, then it's not wise to run static route alone. So it's better to run dynamic routing protocol because dynamic routing protocol help you to manage your network better. It will provide redundant path for you automatically, and most importantly, if the main path goes down, then the redundant path or the alternative path will be automatically brought up, okay, and then without human intervention, so that you will minimize your downtime. So dynamic routing protocol is suitable for all topologies where you have a lot of routers, especially in big networks. So it's generally independent of your network size. It works for small network, it works for big network. Okay, and most importantly, it will automatically help to choose the next best path. It adapts the topology to reroute packet traffic when certain network is down or when certain link goes down. Okay, so all these are done automatically by the dynamic routing protocol. Disadvantage is normally more complex to implement. Okay, so dynamic routing protocol requires you to have some knowledge about how the routing protocol works. It's less secure because the routing packets are sent between the routers. Okay, so when there's routing updates that sent across, a hacker could connect to your network and gain information about your network through these routing updates. Okay, so in order to overcome that, we can do additional configuration, okay, to secure all these routing updates. Okay, and also the route depends on the current topology. So as the topology change, your route also change. So sometimes it can be a bit more difficult to troubleshoot. Okay, and also because you're running dynamic routing protocol, okay, you need to set aside CPU, you need to set aside RAM for the routers to run all these routing protocol. So this may slow down your routers. And also bandwidth, because the router are sending update information to each other, you also eat up some of the bandwidth.